so we're going to look at our next exponent rule, and that is taking the power of a power. And so this one I find to be kind of tricky because it kind of takes some things and your numbers can get really big really fast. So let's look here. You have on your formula chart, it's going to say a to the m raised to the n power. So you can see that's in parentheses. That means it's going to apply to everything inside that parentheses. And so what you're going to do to your exponents is you're going to multiply them. And so you can see here, now here's what makes this super tricky is that coefficient out there in front, because I'm going to take that coefficient and that exponent on the outside now is going to apply to my coefficient here. So, but I'm not going to multiply it. It's not 4 times 2, it's 4 squared, which still follows the mathematical rules. And so I would still get 16, and then I have x to the 6th because 3 times 2 gets me there. So 3 times 2 would give me my 6 here. So let's take a look. This first example, again, very similar to what you had just a while ago. So this 5x to the 7th power, all of that is raised to the 3rd power. So essentially, this is what this looks like. 5x to the 7th times 5x to the 7th times 5x to the 7th. Now, I guess technically you could work all that out by following the multiplication rules. So, but we're not going to do that. I'm going to take this 5. This 3rd power is going to apply to the 5 because it's inside the parentheses. So 5 to the 3rd, and then x to the 7th to the 3rd power. So you see there what I did there. So I'm going to take 5 to the 3rd, and then I have x to the 7th to the 3rd. And so remember my exponent rule there says I'm going to multiply those two. I'm going to do 5 to the 3rd power, which is 125, and then x to the 21. Hey, guess what? If you did this, get the same answer. So if you would like to break it up a little bit, especially if this number is not very big, you can do that. However, you may not always be able to do that, so don't rely on that all the time. So let's look here. Okay, so this is our final answer there. Sorry about that. We have an 18x to the 6th divided by 9x to the 3rd. All of that raised to the 3rd power. So what I'm going to do is inside the parentheses first, I can go ahead and simplify that. So I'm going to take this. I'm going to say 18 divided by 9 is 2. So let me do this. 18 divided by 9 times x to the 6th divided by x to the 3rd. All of that raised to 3rd power. So I don't want to just forget about that 3rd power part. So I have 18 divided by 9, which is 2x. And remember, when I divide, I'm going to subtract. So 6 minus 3 is 3. And then all of that cubed, right, to the 3rd power. Then I'm going to say 2 to the 3rd, and then x to the 3rd, raised to the 3rd. So then, remember my exponent rules say I'm going to multiply those two together. And so I still have 2 to the 3rd power, which is 2 times 2 times 2, which is 8. And then I have x to the 9th power, so 3 times 3 gets me there. So what makes this kind of hard sometimes is that you want to apply the exponent rules to the coefficient and the coefficient rules to the exponents, and you kind of get those backwards. But again, just kind of take your time a little bit and make sure is this applying to an exponent or a coefficient, and asking yourself that. All right, so this last example here, I am raising something to the 4th power. I also have something here. I have division, and I have 2 variables here, so it's going to take just a little bit longer. So what I'm going to take this. I'm going to have 15 divided by 5 times x to the 10th divided by x to the 5th, and then y to the 12th divided by y to the 4th, and then raise it to the 4th power there. So I'm going to go ahead and divide my coefficients. So those are the big numbers out front. So that is going to be a 3. And then remember, when I am dividing, I'm going to subtract my exponent. So I have 10 minus 5, which is x to the 5th power. And then I have a y to the 12th minus, subtract. So 12 minus 4 is 8. So y to the 8th. And then all of that is raised to the 4th power. So again, I could kind of separate this out. So I have 3 to the 4th times x to the 5th to the 4th times y to the 8th to the 4th. So these numbers do get pretty big pretty quick, even the coefficients. So I have 3 to the 4th is 81. So I have 81x, and so my coefficient rules say I'm going to multiply here. So I would have 5 times 4 is 20, and then I have a y, and my coefficient rules say I'm going to multiply there, and so I would get y to the 32nd. Again, these numbers can get pretty big pretty quickly. So don't be afraid if you see something that's kind of like a bigger number, you're like, oh, I don't know if that could be the right answer. It probably is, especially when you're talking about taking something to a power and we're multiplying there. It gets big really quickly. I will tell you with this power to the power, you're going to probably see it coupled, okay, grouped together with other exponent rules. With our other exponent rules, you're still going to follow PEMDAS. So remember, like, you still want to apply, take care of what's in the parentheses first, simplify there, then take something to the exponent. So that exponent is that second, is that E, okay, that order of operations, but you want to take care of what's inside the parentheses first. And the mathematical procedures with the coefficients. So remember, you're still going to divide or multiply or whatever, or take to the power of those coefficients. They still follow those mathematical rules. And then the only part of the expression that will follow this rule are the, again, the exponents. Again, you're going to, if it's in parentheses, it's going to apply to the coefficient as well, but that coefficient is going to be raised to that power, and your powers are going to multiply together. Again, one more piece to kind of this big puzzle of, simplifying these expressions.